Hi guys, Mr. Johnny here. Another quick video, supposedly quick. Another LED bulb, this time it's a global 12 watt for this 1000 Kelvin, nice temperature. It stopped working. I did muck around with it before, but all I did is I just, you can see, took it apart, looked at what's inside, then packed it all together. It worked for a while and then died. Yeah. I even measured the power factor, which is 0.98, very nice. It has a nice little buck regulator, but it stopped working. And to test it, I went and looked at the chips through a magnifying glass, and I could actually distinctly see 3 separate chips in series. So I know to light them up I need, like, safely, I need 2.5 volts per LED. So I whacked 7.5 volts on the power supply right now. Just went and used these two couple of needles like this, pins, little pins, and I just make sure, and I went on all LEDs, I tested them like this. You can see they light up. At 7.5 volts you do not have to bother with current limiting because the LEDs are not turned on a lot at all. As you can see, they are barely lit, which is has additional advantage that it doesn't blind you, because at 8 volts they are pretty damn bright, at 7.5 they're fine. But again, look how many LEDs are there in a package. So obviously the problem is in driver, but before I dive in, I'm gonna, just for the hell of it, take another lamp and whack it in there. Maybe the problem was in a socket, intermittent, some kind of pesky problems. This thing does not have a switch, so no, it's plugged in and nothing. So now I'm gonna just go and desolder these wires. Okay, I was desoldering wires and that happened. I was like desoldered this positive wire. I just took my finger and slid this wire off, and I happened to touch this LED and off it came. How hot does it have to run? Jesus Christ. I mean, like, take a look at the pad on there. Talk about crusty. Jesus Christ. And the LED. And I kid you not, I had another bulb just like this one, global 12 watt. It had exactly the same problem. I actually made a video taking that apart, but I binned that video later because I babbled for way too much there. So you never saw that video. But I kid you not, I had exactly the same bulb with exactly same problem. You can see the LED there in all its glory. And the funny thing is that I went through all LEDs and they're all fine. They all lit up. Let's just go and check other LEDs. Just wiggle them like this. Try to peel them off. Maybe I'm gonna be lucky and peel one more off. Okay, the other ones seem to be intact. Oh, so I have to solder that back in, but that's next to impossible on this PCB. And so, just so you see, I'm gonna go right now and test it again. Okay, let's see if I can do this. This thing is extremely small and picky. You can see that, hopefully it's in shot. It lights. So it's not the actual LED, it's a solder joint which failed. Let me think it through. To hell with it, you see. I've just put a nice blob there. Take a look at that. It's pretty hefty blob there. The thing will be just fine. The driver there will take care of it, the same current will be passed through the LEDs. Maybe it will change a little bit, it's not ideal current source, but it ain't gonna change a significant amount, period. But because there is less LEDs in series now, the total voltage drop is gonna be less, and the current is gonna be the same, so the power will drop anyway, which is a good thing, because that means that the thing will get a little bit less hot. And these things get blazing hot, if you ask me. I just do not like how hot the manufacturers run these. Inside there is a little board which is pretty damn similar to the board that you saw before in the video called Derating an LED bulb. Plug it in here, put it there, put a focus there, and oh. Whoa. Shh. Well, I hear arc in here. Interesting. I soldered the wires the right way around. The thing did not light up, but I heard arcing going on whenever I plug this in. So there is some continuity. And this is definitely a good joint here. You can see that this wire is a little bit pink-ish in color, and that is soldered to the positive, so it's definitely right way around. So seems like I'll have to take it apart anyway. Oh well. Again, the thing is that son of a, this thing gave me a zap. Not a big one, I totally overreacted, but it got me by surprise, alright? I'm not a wuss, I used to 100 microfarad 400 volt caps discharging into my finger, so I'm not all that critical about it. But this thing got me by surprise, let me tell you that. It's probably the input filter. I mean, capacitor across the line. What I wanted to say before I almost got dead by that zap. This bulb is kinda expensive, you know. This bulb is a cheap bulb. It's a crystal bulb, just like the other one I modified. The funny thing is that this costs twice as this. I can literally buy 2 of this, which are 12 watts by it's the same color temperature pretty much. You can see I can buy 2 of this for the price of 1. So far this did not fail, not a single one of them. This one, again, it's a second one that had exactly the same kind of failure, so it's a pattern failure now. Honestly, I did not have these bulbs, these crystal bulbs, as long as I did these global ones, but we'll see. If these bulbs ain't gonna last as well, I'm definitely gonna make a video about that if I won't be dead by that time. So, yeah, let me get inside. By the way, you can see how cracked this wire is. The insulation gets brittle with heat. I found this screwdriver in the garden at my grandmother's house. You can see the handle is all in the concrete, and the tip is a little bit crusty, but it's excellent for prying stuff apart because I don't give a shit about it. Just whack with all the grunt you have and you'll be fine. And so will be this, because it's a Soviet stuff, and although it looks like shit cosmetically, this thing will last. A lot of these bulbs. Heating compound. That's what I'm talking about. God damn it, still managed to get myself into this. By the way, honestly, as I took it apart, I took this diffuser off, I gave it a sniff, and I smelled a burnt driver, you know. It smelled like a charred PCB. Not a charred, but oh boy, PCBs that got hot. Yeah, let's hoik it out here. It's quite a big board, quite a different to the other one. You get the idea. I take this off, then I kinda crimp this off, and the thing will come out. Okay, it didn't go as smoothly as I wanted, but you can see the heatsink there. The board is a little bit more complex. And here is that moron that gave me a zap. As you can see right there, 150 nano, 275 volts AC. Fusible resistor 10 ohm. Cap across the line to get rid of some differential mode noise. Bridge rectifier. Bulk capacitor. Control chip. Freewheeling diode. Output cap. Another choke, which goes from the output of the rectifier, as you can see, down to positive of the bulk capacitor, I would reckon. Yeah, here you can see bulk capacitor is right here, and here is a choke. It's, what is it? Oh, you know what? I'm so glad I looked at the choke to see the value, because I think I have a problem here. The value, by the way, is brown, green, red, which is 152, which is 1.5 millihenry. But take a closer look at the choke. Right there. Seems like a crack to me. That's funny. That's the first time I see this problem. Let me ohm it out and... Okay, 20k range. This choke is definitely has to have lower resistance than that. And it's nada. Fantastic. I kid you not, I did not do any troubleshooting beforehand. I just went alone. And it's nothing. And my probes are not open. Great! So with this choke, which I can ditch because the thing is gonna produce more noise, but so what? The other one does not have the filters and they still pass. Or maybe I'll replace it. Let me think about it. Let me give you a macro shot on that, so you can see the crack. Here we are. You can see that between brown and green stripes there is a nice crack here. And there is a nice crack going right in the middle, smack in the middle of the silver band. Nice. Okay, and maybe you want to know what the chip is. I think the chip is Bright Power chip. According to Big Clive, BP stands for Bright Power. And this thing just refuses to focus. Alright, see? You can see some other components here. Current sense resistor there. Freewheeling diode ZES1J. Some other bits and bobs. Let me get a better number on it. Even after heatsink compound treatment, I think it actually made it worse. Anyhow. Okay, I went and installed 1 ohm resistor instead of a jumper across the choke, which is still there. Okay, I used the figure 8 or figure 8 connector there. By the way, yes, I'm gonna say it again. If you're not familiar dealing with these circuits, do not follow anything in this video. It's kind of a common sense. Do not go where you don't know, into the areas that you don't know. Ta-da! And we have light. And I did not run it for long because the thing is without heatsink. And this capacitor is not charged. Great. And just for the fun, I'm also gonna check ESR of those two electrolytics. Okay, ESR meter. Check the knolling, you can see it there. Input coupling. Oh, sorry. Bulk capacitor. Not great, but... And yes, I discharged the capacitors beforehand. Output. Oh. Okay. As you saw, the input read something, the output did not at all. The output is 1 microfarad 400 volts, so it's not a big surprise. This meter goes to I don't know, about 10 ohms max or something, so it's probably more than that. Let's use a transistor tester that actually tell me. There is a function here which I can select to test capacitors in circuit. Test point 1 and 3. If you can actually see what the hell it reads. I think you do actually this time. So input capacitor, .29, 6 ohms. It's 4.7, fine if you ask me. Output. Now output has a 150k resistor in parallel to it, so it may show a little bit of leakage. Huh. It doesn't show anything. That's kinda interesting. God damn it, this video is gonna take ages. I wanted it to be a 10-minute video, and here what I get. Okay, capacitor liberated. Let's test it as usual. You can see 31 ohms. No wonder that... There we go. 30 ohms. No wonder that my meter could not see it. But it is there. Both caps are Aishis, as you can see, 105C rated. Actually nice capacitors. I did not see much of them failing in these things. And they live in hell, pretty much. As you can see, the PCB is discolored here. The thing gets hot. I actually went and reflowed bunch of connections here as well, and I kind of found a nice touch here. As you can see, 100 ohm resistor here and this capacitor across this rectifier. It's an RC snubber to dampen any parasitic oscillations there may be between the capacitance of the diode and some stray inductances in the circuit. That's a nice touch. And the thing is soldered fine, unlike this actual board. You know, I decided to go and whack that 1 ohm resistor there and it'll be fine. Okay. And it blinds me. It's hammer time! Okay. Did the same as I did on the other bulb. Just went and mushed aluminum over, pressed it in. This little bit may need to be soldered. Although I think it's gonna make fine contact as is. The base is a bit loose. But you know what? I'm actually gonna replace this bulb with this bulb in my work light, so which is this desk lamp. I am the only person who uses this, so I don't care that this is open and live, because the buck regulator is not isolated. Plug it in, and ta-da! I have light. Yay! Does not shimmer much, that's good. How much it's gonna last? How long is it's gonna last, you might ask? I have no idea, but honestly I don't care. It was already a piece of trash, right? So it was if I wouldn't have handled it, it would have gone into trash anyway. So if it's gonna go in trash a little bit later, so what? I'm gonna extract as many service hours from this as I can. Thanks for watching. See ya. Yes, I am a cheap ass.